This conference will now be recorded.
Today's topic is going to be the non-IT equipment power. What are the items we want to go into that bucket? And we want to get the review and get some alignment here.
Okay. Well, why don't you start, Samia? Then just do a quick overview, and then I'll start. I'll jump in a second.
Okay. So basically, what we kind of started looking into, we had 3-4 different presentations before Mohan came and presented on what are the different metrics that we want to look as part of that DCEM, what we want to focus on it. Obviously, there is a PUE and all the carbon related and water related items that we want to look. Basically, what we really want to focus today on PUE, if you want to augment PUE, even if you look at PUE, we don't have a complete definition of what are the things going into that PUE. Again, given PUE is going into the range of 1, nearing to 1, we want to have an expansion on how do we differentiate between IT power and non-IT power, especially when you improve the performance. We want to see a better number, but if you look at it today, it's going backwards. If you increase the performance, we are seeing PE going up rather than going down. So we want to holistically look at the OCP system and what are the different metrics that we want to represent, or what are the information we want to collect. But before we can collect, we want to understand what we want to go into that IUE, so that we can come up with a list and align on whether we are okay with that particular list. Anything else, Mon, or anybody else want to add to that?
No. I have
Mon,
to switch.
Yeah.
Oh, can you hear me? I have to switch laptops. It's on my other laptop. Just give me 1 second. I'll be right back.
Sure.
Just have to rejoin the call.
While we are also waiting for Mohan to join, let me flash a couple of screens that we want to get alignment here. So these are the 4 things that we want to figure out some augmentation on the OCP side. PUE, WUE, GWP, and CUE. And each one, I think we discussed, there is improvement can be made, and we want to align with certain items for each items. And today we want to focus on the PUE side. And also, I think one of the opportunities we said, like sampling period, number of samples, static versus dynamic, partial versus full, IT energy constraints. And do we want to consider fan, and how are you going to deal with immersion cooling, and all these things we really need to spend some time to dive into the details.
Can you hear me?
Yeah.
Okay. So
I'll stop sharing.
go ahead. I think let me just start to let me just refresh on one of the things and then talk about some of the issues that we're going to face immediately. Sorry, I guess it's a luxury. I have 4 laptops. I have to figure out which. Can you give me sharing rights, Sammy?
Yeah, I'm going back. Yeah, you have it now.
Okay. So if you remember, one of the reasons, actually, let me see if I can get to that. One of the reasons why we wanted to, I had shown why we wanted to look at something other than PUE because PUE itself was something that's approaching 1, right? So when PUE approaches 1, then you kind of have no place to go with your metric. Wait, is it showing?
Yes, we can see it.
I think it's showing the, it's locked in on one slide for some reason.
It's showing the infrastructure usage effectiveness. So slide more.
So start, let me. Maybe I just do entire screen and see if that makes it any better. Now?
We're seeing the same screen. Did you change the screen? Or?
Yeah. I hate all these tools. Why can't everybody just use Teams? Now? I think it's showing the sustainability metric screen, right?
No, infrastructure usage effectiveness. I will unshare and share it back and see maybe.
Yeah, I can just talk to it. It's okay. If it keeps breaking, I'll just talk to it, and we can pull it. It's not much. It's just if this works this time. Nope.
I'll make you as organizer so that you can maybe there is something going on the.
Okay.
Yeah, now I can see different screen.
Okay. So hopefully this keeps working. Now it still shows infrastructure effectiveness, right?
It shows infrastructure effectiveness, but it was showing some other screen when you probably.
It was showing like your laptop background.
Oh, that's even bizarre.
It says Lenovo and
Yeah, now we can see.
ooh,
Oh,
Yeah, don't go full screen maybe.
yeah, maybe that's my problem. Okay, so I'll just stay off full screen. Hopefully it doesn't. So one of the problems we talked about was we wanted to go from PUE away from PUE because as PUE approaches 1, where do we go, right? So we need to come up with a different metric, and that's why. I mean, and you guys know, right? So lots of the recently coded PUEs are all in the sub 1.1 for sure, right? And I've seen 1.03 type PUEs at this point. So it's getting to a point where the metric is not very useful when everybody's coding number close to 1, when the ideal number is 1. So we talked about doing infrastructure usage effectiveness, which was essentially saying, here's the IT power being fed into the server, and then how much of it is actually going to CPU, memory, and drives, right? So, um, and, so the presumption there is that in a traditional server architecture, you have cooling losses, and then you have power losses from the PSU itself and all the VRs and DC to DC converters and everything that's in your platform. So that ratio basically gives you the power you supplied versus the power that actually went to power your electronics per se, right? Uh, so so this is a good way to think about it for a traditional server design. So now we have a problem. So as you start to measure this, I mean, it's great for most of the designs that are out there, but I want to caution about some of the trends that are there that are going to just knock us out of this equation too very quickly, right? So in uh, in our data center facilities team, they are working very actively on liquid cooling. As liquid cooling catches on, especially if you think of things like immersion, the fans just move out of the server eventually. So the thermal losses that we are counting in based on fans and so on, they just go away, right? So there are no so fans depending on what kind of system you have, they account for about 10% of the losses today. So those 10% will no longer be part of your IT hardware, right? Whatever you're supplying into in your motherboard, that loss is not there. It's elsewhere, right? It's at a system level. And then you look at power, and then you take something like the OCP bus bar that's being used in really creative ways these days. It's consolidating power at a rack level, which means the power that's arriving to IT power has really uh, I said no losses, but no major thermal or power losses like it did in a traditional architecture. So then your IU is limited to, the heat losses from your electronics, and I wrote it wrong, and the VR losses inside the thing. So now instead of starting at this, 10+% uh, that you were earlier in a traditional rack architecture, if you think of an immersion cooled busbar design, you'll be starting off your IE again uh, close to close to one, right? Because your computational energy is, I mean, your IT energy is pretty close to your computational energy. I mean, in a way, it's good for the world, right? That the designs are converging so quickly. So, but then if you want to measure the losses in such a system, they are occurring at at a not exactly at a facilities level, but somewhere between the facilities and a server level, and we have to account for that, right? So, for example, that bus bar is not without its losses. The immersion cooling, it's not without its, uh, you know, uh, heat efficiency issues. So now what we have to do is introduce yet another concept to comprehend these things at an aggregate level. So I think while we talk infrastructure I mean, the one lucky thing that we did was we never mentioned when we said IT equipment. The implicit assumption was it was a server, but maybe the implicit assumption it's a rack. If you think of it as a rack for those things, then everything works out. So you still have the same IT energy minus thermal energy minus power conversion loss. All of these exist in this thing. But if you if you always assume that you're at a single server level, then yeah, things are not going to work out again, essentially. So I just wanted to say that I mean, it's wonderful that the technology is changing so fast that we at the cutting edge can't even keep up with it. So that's really, really great. But that also means that we have to work extra hard to comprehend these uh, uh, changing architectures, and maybe even think about what things would be like uh, if uh, if even more changes occur in there.
Can you define, Mohan, when you say rack in a immersion world? Can you help me to visualize
Like a whole tank, an entire
an
tank.
entire tank? Okay,
Yeah.
gotcha.
So more, so the we are not really like reporting what do you call system level uh, IUE, right? So we will be reporting data center level, right? Or are you thinking we should be reporting system level, rack level, and data center level?
No, so originally it even made sense at a single rack level, right, Sammy? Right. So
Right.
now I'm just saying that as as the as the system level designs are changing, we do need to come up with a better answer, because the system level answer may not be that great. We need to essentially figure out sub data center level, not exact. So what is the consolidated system may be different for you, right? So in my mind, think of a server as whatever is the container that holds everything together. So that may be one rack, or that could be, so that could be one rack or one tank, or just one server. That may change on you. So we need to define it, yeah, for multiple physical configurations. Is all I'm trying to say.
Okay, got it.
Sorry, so we are saying that this IOE will not be a data center level then. It will be a sub data center level, which like
I think it should be a sub data center level in my mind. I'm just saying it cannot be just a rack level thing, like PUE was, because I think we have a problem if you design it that way. The world is changing too fast. That's all I'm trying to point out.
But I
So,
would say, to Shruti's point, when it gets to the level of regulation, they'll want to know across your data center, and let's
right.
assume you have some immersion and some, older equipment and some bus bar equipment, they would kind of want a number that weights each one of those appropriately and rolls it up at the data center level. So that's something to think about too.
Uh, yes, yes. Uh, I, all I'm saying is that we need to define it. Uh, we need to define this in a tight fashion. Is all I'm saying. So that's and I mean, not that we cannot. Uh, we just need to work on it, right? So we'll let me see if I can show you the presentation we made to the management work group, so you can see all the variations that you end up with there. But do you see the issue that I'm pointing to? Right, essentially we have to define it at a different level. We can just say, I mean, so okay, let me tell you, maybe this is just me, right? My worry was, by drawing a picture like this, I was implicitly assuming a server architecture, and we can't do that. Is all I'm saying. We cannot just show such a server architecture, because that will just break apart on you.
yeah, I think in our words, nothing. What we're really saying is we need to have a some way to represent data center as a sub items within the data center, right? Either
Yeah,
a rack level or a what do you call container level, or however you want to split it. But the sub items, when you do a sigma, and I don't know, however we want to sigma the IT, non-IT, and divide it, you want to get to a data center level. We need to get the
right,
formula for that, right?
right, right, right. There is the data center level. We don't participate, because that's the job of facilities. But everything After that level is something that we need to go comprehend in order for us to have an effective metric. That's all I'm saying. So, Sami, first of all, I didn't know if this is where you wanted to go, but this is where I was thinking that. I mean, again, the same issue exists if you want to look at like forget immersion cooling. If you think about like cold plate, same issue, right?
Yeah,
So
yeah.
little bit different, but still there are losses are very minimal at your rack level, because at the rack level you're running your fan at a much lower duty cycle. So lots of the losses that used to exist in your server have just kind of gone away at that point.
Yeah, I think this is what we want to refine more. I think we really want to define a system level, rack level, and a DC level, right? We need to get that definitions right, so that we can start reviewing that, right? So we need to start putting the draft. What
Right,
does that
right,
means, right?
exactly. Exactly. So as we get closer to the OCP Global Summit, we need to uh, work on the next level of stuff, uh, and let's say, here are the various uh, configurations that could exist, and then for each configuration, what does it look like? So the most challenging configuration would be something that's a bus bar and an immersion core. Then so much of it is at a tank level for you. Right, again, I think this is limited by your imagination, right? So somebody else, one of you may come up with an even more challenging configuration that I have not thought of. But so I think we're going to continuously be in this mode where uh, what's considered IT hardware is so small and so little, so less in its losses in general, that we have to go to a much coarser aggregation for it to make sense.
So they're more like once
Go
you
ahead.
go ahead, Shruti. Yeah.
I was just going to ask, what are we envisioning, or who are we envisioning will need to use the subsystem level IUE? Because the DC level, we understand if there is any declaration or regulation, etc., they tend to look at the DC level. But we are saying that we want to declare it at subsystem level because it is helping. Whom is it helping?
It's help. So I think the whole point is how much of our energy is actually going to IT hardware versus how much of it is going to power and power and cooling losses in general. And our goal. I mean, sustainability. Our entire goal, whether it's PUE or IUE, is to essentially minimize those losses. And I'm saying that uh, at the granularity that you look at, then the losses may just go away. Just like it went away for PUE, it may also go away for IUE. If you just take one blade in a immersion tank and look at it, then you're not going to see very, very much losses in there, because the losses are happening elsewhere. They got aggregated away or disaggregated, whichever way you want to think of it. So you have to look at it at the right place to see the losses happening, because our job is not to make IU equals to 1 immediately, right? Our job is to see these losses go away, right?
Yeah, I'm imagining, Shruti, that, within a facility when people are going to have to make trade-offs, right? Cost, effort versus, risk versus moving to different architectures or different implementations, be it cold plate, be it immersion, what have you, right? And so those are the people that would probably use this metric, I think, to kind of make some trade-offs and to decide where to go and to track historically, here's where we used to be and here's where our newer architectures are taking us. That's my imagination of how this would be used.
Yeah,
And
yeah.
I think I don't know the names of those people. I'm sure they exist, like data center architects or data center designers or something like that.
So in other words, actually, in OCP, we are creating systems and racks, right? We are not really creating a data center. So what we want to do is we enable systems and rack level, whatever we want to measure, right? So that we can able to represent the data center level, right?
That's a good way to look at it.
Yeah, that's a good point. You know, PUE is purely facility. You know, that's it with the system dividing line currently at the input to the IT equipment of as you described. So having a
So I think
rack level metric is interesting.
Yeah, so that's all I'm saying. Yeah, rack or rock, and I don't even want to say rack because it could be a tank, and it's the
Yeah.
next. It's whatever is it's whatever is the aggregation that consolidates a bunch of IT hardware together,
Mm-hmm.
right? The lowest level of aggregation that consolidates IT hardware together, and that's what we need to define this as, and then everything works out. If you don't do that, then I think it's you, you're it's it's not gonna work out very well for us because it will be back to converging to one very quickly for you.
tomorrow, maybe next meeting, we should put together a kind of sample rack or tank or what are the things we want to include. We should define it so that we can say for this, all the configurations that what we are proposing, the metrics can work, right? What is included in that each one.
Yeah. So I can. Again, Sammy, I'm struggling with the presentation being elsewhere. I don't want to make you guys go through another as I switch from one to another the call. But maybe next time I could just show you all the various configurations that we potentially have coming up and how this will apply. The good news is that I think it does work, and we should just keep marching on. It's just that we need to define it tightly so we don't, we don't kill the metric before it even starts.
Yeah.
Right.
Yeah, I'm intrigued by the idea of defining the aggregation, this rack level thing, right? So you get away from the server level, you're not at the facility level, but this rack, if you define that and then the metric around it, that's interesting.
Yeah, rack or you want to say container or
Whatever name, rack thing.
Right.
Yeah, whatever it is.
Yeah, sub DC level, however you want to separate it, right?
We can make just
think,
a bunch of servers, just JOB. We can make up a new acronym, right?
yeah, I would say not to use the word container because that's a very
Right.
well-known word in the context of software and Kubernetes,
Right.
etc. So we need a different word that won't confuse people. I like the acronym idea. That might keep us from this overloading.
Also, depending upon how the definition of this not container but some subsystem goes,
Yeah.
I'm sort of wondering that if that becomes an area that is gamed after that, because it can probably have a very broad set of implementation for any given definition.
Well, if we're worried about being gamed, perhaps we can be very specific on how one measures it, right? And
You mean specific about what is included in that subsystem that we are going to talk about?
yeah, and like we've talked before about the frequency of measurement or the duration of measurement, right? All, kind of
Right.
being specific around all of that makes it harder to game.
Yeah, that all we can define, but particularly, defining what is the subsystem where you're going to measure, where it is not a clear term like a DC. Like
Yeah.
if you said something like a rack, that a rack could be 10 different configurations. 50 different configurations of that. So
Mm, absolutely. It can have a different kilowatt rating, right, starting at the high level. And then there's what's actually in there. I mean, this is my view of this metric is that you don't want to game this metric because you want to do the best you can for your data center. Make the smartest trade-offs you can when you're putting equipment in your data center and making purchasing decisions and all of that. So gaming it would not, would not meet that desire.
So once we go to the rack level, how do you want to represent the switch or the what do you call gateway and other top of the things that's outside the rack that
The
to be in the data
the
center?
the switch, yeah, like the networking, you
Right,
mean,
right, right,
Sammy,
network,
right? And the,
right.
the cable. So again, I think we can, that could be part of defining what the boundary is.
yeah,
So this one, Mohan, like, is it assuming the racks are operational or not? I'm trying to say in IUE, how are we going to aggregate them together? That's what I'm kind of looking. Mohan,
So
if you're speaking,
Mohan, the
you're,
fact that you're showing
you're
this
mute.
picture leads me to believe you thought about this deeply. So do you want to share
Mohan,
with
you're on
us?
mute.
There we go. Sorry, I'm on mute. Sorry, I was
Oh,
talking
you
to you guys.
were speaking and wondering why we weren't.
Yes. Like, why are you guys not responding back? Sorry. So I was thinking about network switches, and network switches essentially, uh, the energy that we're supplying to the network, uh, you know, to the if you think of it as a partial PUE, network has to be different, actually measured differently, right? So your total energy to the switch divided by the the amount of bytes that you move is the actual energy movement, right? That's the value that they are delivering out of the switch, the value delivered per for a unit of energy. That's what that a network switch should be measured by, right? Because uh, more than efficiency, it's it's the uh, it's the efficient transmission that matters in a networking environment. Because a lot of the things that we take for granted in a server environment, like or in a client environment, like power savings and dynamic voltage scaling and all that stuff, just doesn't exist in the networking environment. They're always on, and they're always, the links are always trained at full speed. One of the things that I've been doing with the networking folks is to come up with schemes where they could also optimize power on the basis of the fact that you know no one is there. It's midnight. There is no traffic flowing through it. You don't have to be clocking uh, your circuits at full speed uh, for no reason, right? So there is a lot of work that they need to do in this space as well. So uh, I had folks actually scheduled to come in to uh, Sabi, we can bring him into your work group also, but they were going to come into the project work
Okay.
and talk about it from a networking company. But it has not happened because this is all very new. So folks are trying to sign the right uh, engagement agreements and join OCP and all that good stuff. But
Oh, cool.
anyway, yeah.
All right. Does that answer your question, Sammy?
No, still, what I'm trying to say is when we get a UE defined, it's a rack level.
Mhm.
Now we want to combine them and to create a data center level, right?
Yeah.
And how are we want to account this network portions to the data center?
You would think of it as a whatever energy you supply to the networking switch motherboard versus essentially the losses that you suffered there. So it would look very much like this IUE portion. Because this IUE, I didn't say what the IT equipment was, right?
Right.
I didn't say that it has, uh, a Xeon server or some other server or whatever, right? So it could be just the switch silicon that you're supplying that to.
Okay. So you basically you put the network IUE
Yeah,
and
it's the
you
same.
combine them. Okay. Got
It's
it.
the same thing.
Okay.
The same thing. But my point was that we need something else in addition to this, which is the energy per byte type metric, for us to do a better job of networking, because it's not sufficient. If you take the way that IUE would take, they may come out saying, "Oh, I'm doing a good job," but they may come out really terrible in terms of the energy per byte metric because of the
Yeah.
issue that I'm saying. They're running all the time, Savvy, right? They just don't
Right.
stop.
Yeah.
They,
So yeah, that is kind of ways. If you are not operating to your max, then you are not efficient utilizing.
Yeah, exactly. So how do you bring in, like, one of the things I'm working with them is that, how do you, maybe shut down, if you have 4 ports, why don't you shut down 3 of those ports? Nobody's using them. At any given time. So utilization based scaling, so you can go up and down. Those things don't exist today. So
Right.
so the question is, can they put them in for the sake of sustainability?
Right. Then also you're conserving energy there, right? If you're
Yeah,
not
that's what I mean.
utilizing
That,
it,
yeah,
yeah,
conserving
yeah.
energy is
Right.
sustainability, right? So
So the
Yeah.
way,
Another thing. Go ahead, Shruti.
sorry, so I was just confirming the way you answered Sammy's question about, how we are sort of including this when we go up to the DC level for IUE. We are declaring that these switches would be another type of subsystem, and there is IUE calculated for those also. And maybe there
I
are
agree.
a number of
Exactly.
different type of subsystems we need to define, and it's sort of a summation, or not summation, but it's sort of an accumulation to get to the DC level.
Exactly. So we need to do all those things, because I think I should change my example here to not say CPU memory drives, right? I should just say, maybe I should just add networking silicon, so it's comprehensive. And then we can make an
Yeah.
example for each one of them.
And
It,
also
it doesn't
storage
matter to
also
it.
more. Yeah,
Yeah.
storage also
So
more. It's a kind of spans across rack, right?
exactly. It
Right.
doesn't matter to us what it is, right?
Right.
So as long as it's IT hardware, then we don't need to worry about this issue.
Right. So I think one of the thing is we don't want to see like people say, hey, my rack is have a really high AUE, but if you add the network and storage, then it's going to look differently, right?
Yeah.
What I mean, the the rack is just compute rack, right? Not a network or storage component in it.
Yeah. I think the reality is really messy. I don't think so. So most of the IT, most of the IT, the networking guys do not qualify things in immersion today. Okay, so as a
Okay.
result,
Right.
even in
Right.
a so-called immersion system, uh, you never immerse your networking. So
Mm-hmm.
you go in expecting like a immersion cool system to be quiet. It's extremely loud, and the reason it's loud is because of these networking switches being outside. So anyway, it's lots of
Yeah,
fun stuff going on here. So,
yeah. But there are some cold plate direct-to-chip networking switches, from what I understand, right?
cold plate is qualified because it doesn't change the characteristics that
Right,
much,
right,
right?
right.
Yeah,
So the fan should get reduced in that case. You would hope.
yeah,
Yeah. Okay.
yeah. But in general, switch silicon, they don't do a whole lot of qualification. I mean, this is our problem, right? So
Yeah.
this is not just the SAMI's work group, but this is a overall sustainability issue. Networking guys are not that motivated to look at power. It's mostly about performance. So changing that mindset is going to be an uphill task in them.
Mm. I did just want to add from a networking perspective, you said per byte, but there is another perhaps aspects we can look at, because in networking there's the payload, the bytes that software actually wants to send, and then there are typically multiple headers that have been appended to the front of the payload, and then some other trailers that are appended to the end. So you just might want to think through that. You know, do you want it to be per payload byte, or do we want people to be
No. So when I said bytes here, mood depth, right? It's essential. So I'm just looking at the bytes mood. So all the
so you're
preamble,
including
postamble.
the headers and all of that stuff.
Yeah.
So and then the other thing to think about is we would like to reward people who compress the data, but because
No,
that
those are the
means
good
fewer
ones. Those are the
bytes.
good ones. We want them to compress, right? Because it reduces the
But
overall energy.
exactly, we
Yeah.
want to reward them. The compression, I don't think it happens at the switch level. I think it tends to happen before that. So I guess we're not going to be able to find a way to reward people that
Yeah, but
do
as energy
compression.
depth, it will show, right? Because if you compress it, the joules per byte is going to be smaller. If you don't compress it, will be higher. But we also want to penalize the people using a lot of header and other extra things that large headers, right?
Well, I think I heard Mohan say he's fine with, if they wind up plopping a lot of extra overhead, it'll
Well,
still just count to the bytes.
it'll count to the bytes, so it will you will if you spend a lot of energy, Sammy, and then you move and you have a massive amount of preamble and unnecessary bytes, then the number of bytes you moved actually will be less. So it's your detriment in some sense, right? You wouldn't do that because it's only going to affect your own metric. So we
So bytes moved from the starting.
no. Okay, useful bytes mode. How about that?
Yeah,
Maybe
that's
okay.
what I mean.
Okay, so payload. So
Payload,
that's
yeah.
at the switch level. A lot of those headers and postambles or whatever are appended prior to the switch. So we would have to reach back into the networking stack and ask them to report payload versus all
Yeah,
the other.
I'll,
Um,
yeah. I think I
as
based on what you guys are saying, I'll just change this to say total data bytes mode. How about that? That'll make it clear. So that's what
so,
we're interested.
are you going to say payload, or are you going to say?
I'm just going to say data bytes mode. So that's essentially means.
That's still somewhat ambiguous to
Yeah, so
people.
You want
useful
to
or
say
In networking, the term I would use is payload.
payload bytes mode,
Yes.
something like that. Yeah, that's.
But again, this doesn't incentivize compression. I think people are already incentivized on the compression part, but that compressing your payload is goodness for sure. But again, it happens
It's not
prior
at the
to
switch.
hitting
It's not
can
at
we
the
say
switch.
raw
Somebody else.
payload or
exactly.
yeah.
Well, and I think, but also payload happen is not known by the time you get to the switch. I don't think the switch adds a lot, if any, header. I could be wrong though.
Yeah, right. So to
Which
Deb's
doesn't
point,
had an header.
I
Yeah,
think,
it very minimal. Go ahead.
yeah, so
Exactly.
to that point, then we actually need to understand the payload bytes getting moved by accessing like another portion of the system. Because
Like
it's
the
not
NIC might know.
right.
And the NIC well could be what's, is doing compression as well, I would say. Although
Yeah,
sometimes it's done by the software.
the switch will not have complete insight to know what is the payload bytes here.
Yeah. And I guess the other thing I would say is when we get to all of these big AI training systems, they're not going to want low energy states. They're not going to want that extra latency to come in and out of that, and I'm sure their vision is that the hardware is used 24/7. So that's just an aside.
Yeah, I think maybe we should start thinking, and probably when we come in next week, let's probably refine this if we want to change the wording.
Yeah, let me
So,
think a little bit more about it. Run it by the networking guys, and then I'll come back
Yeah,
on.
yeah.
so Mohan, next week we want to kind of put together some of the Sigma formulas and other things, and so that we can define what is the rack and how are we going to aggregate them together, and then a definition for each.
Yeah, let's. So I think I can just. So I think my pictures are in another deck, Sammy. So I'll consolidate
Mhm.
everything and then show you, show everybody the full picture for IEE first, and then we'll come back to networking separately from that, because networking deserves its own thing, and I would rather have
Mhm.
some of the networking people join us also for that discussion.
Okay. Yeah, let us continue the discussion next week, and let's come to a kind of aligned definition before the summit.
Yeah, sounds good.
Okay. Thank you, Tim. We are already top of the hour. We'll see
Bye.
you. Yeah.
All right.
Bye.
Thanks, everyone. Bye.
Thank you. Thank you, Mohan.